This video is brought to you by makeITsimpleTT, the premier online learning space for CSEC IT and computer science classes in the Caribbean. All our classes are run on the familiar and secure Google Classroom platform. The weekly videos are well laid out and labeled by topic, dated, and placed in reverse chronological order to ensure easy access even if you miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. So, we're going ahead, representing algorithms. Here we go. So when you're representing algorithms, you have to think of two major things that you're trying to figure out. You're trying to figure out how to speak to the computer. So your real goal is you're trying to figure out, okay, how do I actually speak to this computer? Now that I know what is input, process, and output, and how the computer sees that it must get the input, the process it has to go through, and the output that you're going to get, I have to now figure out, okay, how do I actually speak to this computer? And speaking to the computer is not as straightforward as saying what you want the computer to do and then getting it to do it. You have to say things in the way that the computer understands. How do you say things in the way the computer understands? Depends on your understanding of variables and control structures. So there are three ways of representing an algorithm, and we already determined that the algorithm is the set of instructions that you give to the computer. So the first way is called narrative. That is using your own words in English. That's kind of like talking to a voice assistant like Siri, Google, Home, Alexa, all those different things. They try to do things in narrative. So we speak and it's supposed to figure it out. But this is kind of hard. The next way you could represent the algorithm is pseudocode. Pseudocode is English that closely resembles programming, so it's closer to how the computer will understand things, but it still has a little bit of English. So it's like the middle ground between computers and English. It's not as rigid as programming code, but it has more structure to it than just normal English. So that's how that works. And then flowcharts will be representing it using symbols. Now the reason we might use flowcharts is because some people may not understand the actual words, but if they see symbols, it's easier to follow depending on where you come from. So in the realm of algorithms, narrative is on this side, and all the way on the other side is the actual ones and zeros. And somewhere along the line, you have to stop and figure out, okay, where do humans land? And humans try to land in a middle ground called pseudocode. That's why we call it pseudocode. And please, for the love of whoever, like, I don't know, please don't ever say pseudocode. If you say pseudocode, I will, like, every time I'm in class and a child says pseudocode, I just be like,
Oye, bye.
yeah, don't say pseudocode. Right. So after you understand that, the next thing you have to grasp is, what does narrative code look like? If I want to read three numbers and display the sum, and I want to write it in narrative code, narrative has a lot of English words in it. So I might have the word start to tell the computer to start, and then I would say something like in a sentence, get the three numbers. Now, under normal circumstances, we would understand what get the three numbers means. But our computers watch this and be like, what does that mean? I don't understand. Because if we use English, the computer doesn't understand English. And then we say add the numbers. If I tell the computer add the numbers, the computer will be like, what does even add mean? It doesn't make sense because it's a language. And because it's a language, you have to speak the computer's language. So narrative is very wordy. It looks a lot like sentences, but a computer can't understand sentences. A computer needs to understand it in a code, and in order to get that code done, we have to learn about pseudocode. So pseudocode now is where we want to get to. In order to get the computer to understand the pseudocode, we have to start to use the terms and symbols that the computer will grasp. So the terms and symbols that the computer will grasp are as follows. Instead of saying number one, we could use shorter terms like N1, N2, and N3. Because a computer really cares about the shortest possible way to get something done. So if we want to say the word number 1, excuse me, yeah, sinuses, right? N1 will actually be better for the computer because it's less things to process. So the next thing is a computer uses something called variables. We'll explain what variables are, but the next thing I'll explain is constants. Constants are used when you have something that is not going to change. So let's say, for example, 9.81. 9.81 is gravity. So I could set G is equal to 9.81 and the computer will understand it. Because remember, at the end of the day, what a computer is trying to understand is ones and zeros. This is all the computer cares about here, ones and zeros. So if you could get things to be in the form of numbers, the computer is happy. He like, yeah, this is what I want for my life. And the other thing that the computer loves to see is mathematical operators. So you see, when you want to say addition, don't say the word addition, put the plus sign. Don't say the word subtraction, put the minus sign. Don't say multiplication, put the asterisk. And don't say division, put the forward slash. And that means that when we are speaking to the computer, we are telling the computer the instructions in a way that it will understand. By essentially what you're doing is you're shortening your stuff. Right? You're shortening all of the English terms to break it down into terms that the computer will understand. But we kind of accustomed to doing that because you would do the same thing when you're dealing with when you're texting people. Now back in the day when you have to text people, you used to only have 160 characters, right? And when you send a text, if it goes to 161, you have to pay for 2 text messages. So we had to find a way to fit things into 160 characters. So instead of saying okay, we were like K. Instead of saying yes, sorry, we were like YH for yeah. Or instead of saying and, we were like plus. So when we came up with text messaging, in order to fit the thing into 160 characters so that you don't spend too much money, you kind of realize you have to shorten it. So it's the same concept. You're shortening the statements so that a computer will understand. So look at this here, narrative. This is a very long statement for a computer. To us, it seems short. So when we say get the 3 numbers, it has to be a lot easier than that for a computer. That's what pseudocode is about. So to go from narrative to pseudocode, you need to understand that there are certain symbols and there are certain terms that you have to use. So those are some symbols. Some other terms I have to use would be relational operators. So if I want to say, check to see if A is less than B. Yeah, if A is less than B, I can't say is less than. The computer will be like, I don't know what is less than means. So what it really wants to see is a less than sign or greater than sign. Or if you want to say greater than or equal to, you use these symbols. So the whole point of pseudocode is use these symbols, not these words, because these words are hard for a computer to grasp. It wouldn't understand it. So it's like talking to the same 3-year-old child. The last example I used, if you're talking to a 3-year-old child, you're really not going to try to use big words like photosynthesis. You will say the trees produce air. You wouldn't even tell them about oxygen because it's too high for them to grasp. So you have to break it down as small as possible because we're talking to a 3-year-old. So when we're talking to a computer, we have to break it down into smaller terms like and or and not an equal sign instead of is equal to. So that's the concept there. You should be good with that, right? So here are some of the basic terms that you use when you're doing pseudocode. Remember, the goal is we're trying to make the computer understand us easily. And in order to get the computer to understand us easily, there are input terms, which will be input, read, and get. So we could say read A. We could say get B. We could say input C. The computer will be like, okay, you see this word here, read? I know what that means. What B is, I know what that means. what input is, and know what that means. All those things are ways that you get the computer to understand how to input something. Same thing for output, right? If you want to output something, you could say print A or print B, and the computer will see that as a keyword. So these here are terms that a computer will understand. So think of a 3-year-old, there are only a few words that the 3-year-old will understand. So you try to use the most simple terms because you're talking to a 3-year-old when you're writing a program, basically. So to set something, you could use set, store, or equal sign, and the computer will be able to figure out each one. Then there's some other terms, if, else if, for, and while. We'll get to these guys later on, but right now we're just kind of handling the basics as we go along, right? So what I was going to say about him? Yeah. So share this with your friends and family and all that stuff. Can you please state it a string? My teacher talked about it. Yeah, we'll get back. We'll get there one day, right? Eventually, I'll get to strings and whatnot. I'm doing this. It's about 8 weeks I'm gonna be doing this for. This is the 2nd week, so we have plenty to go through still. So let's go on. Now, we know the terms that a computer understands, which will be read, input, output, write, get, and we know, okay, anytime we write in pseudocode, use any of these terms, and the computer should be able to make sense of it, or we should be able to be, it will be able to follow the rules of the program. But a key thing you have to remember is a computer processes everything as ones and zeros. Everything that a computer does comes down to the numbers 1 and 0. Every single thing. Nothing happens without 1 and 0. So in order to meet the computer's needs, meaning for it to understand everything, you have to be able to get everything down to a number. If it can be represented as a number, then represent it as a number. It makes life easier for the computer. So that now gets us to data types. We understand as humans have, well, humans who do English, we have the letters A to Z, common, letters A to Z, capital, and the numbers 1 to 0, well, 0 to 9, sorry, 0 to 9, and we have then special characters and whatnot, right? Right. We understand all of these things as humans. A computer does not understand any of these things besides the number part. So it's easier for us to represent things as a number for a computer because the computer would be like, oh cool, I know what a number is. That's how I live. I deal with things in numbers. So the first thing that a computer usually understands is something called an integer. Integer is a number that could be positive or negative. So that would be like 20, negative 55, or 127. Once it's a positive number or negative number, but it has to be a whole number. Whole numbers meaning no decimal places. So tick. If we speak to the computer in integers, computer is happy. Floating point or real numbers. These are numbers that can be positive or negative, but they have decimal places. So they will always have a decimal place. So even if you put the number 10 as a floating point or a real number, you'll get 10.0. Or if you put a number like 9, you'll get 9.0. Or if you put 9.2, it will be accepted. So this is the second thing that a computer loves. It loves to see decimal numbers. So whether it's a whole number or decimal number, the computer is happy. Not a problem, right? Is this person here? No June 2021 paper 2 solution. Does anyone know where I can find it? My guy. If you're on this channel, all you have to do is search for the June. Just go to the channel and search June 2021 solution. You'll see I worked it out like a long time ago. I mean, it's real hard to tell all you to search YouTube. It's there, dog. It's there. Right. So back to this. The next thing that a computer understands is characters. Now, really and truly, what we have done is we tricked the computer into thinking, okay, our character is really a number. This video is brought to you by makeITsimpleTT. In every CSEC IT class, assignments are given on a weekly basis covering the topic that was taught in the class. The assignments are original questions and test the entire syllabus and model the style of questions that come in past papers. Monthly reports are also sent to parents and guardians showing the progress of students. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799. So what happens is when we put like a G, right, or the letter G, what that really translates to is a number like 001010. So there's a code. So we figured out, all right, if you create a code for the letter, then you assign it to you create a number and you assign it to a letter, then you'll be able to find it. So the computer understands characters, but really not understanding what a G is, because under all circumstances, a computer has no idea what a G is. All the computer understands is the numerical code that we've created, which is 01000. Because when a computer sees the letter G, it just be kind of, what just happened there? It not making sense. It is like,
you've said some pretty shocking things here. Wait, hold up, wait a minute.
Yeah, so the computer will be like, G? What is a G? A G doesn't make any sense to me. And then we would translate it down to the zeros and ones, and then the computer will be like, oh, okay, makes sense. So these are the three things that a computer can understand. Everything that we do when we talk to a computer is built on these building blocks. Either an integer, a decimal, or a character. And everything else that we do, creating words, sentences, games, graphics, all them kind of things, they all come down to ones and zeros. But these are the three data types that we use to make sure the computer could follow our instructions, because at the end of the day, what we're trying to do is get the computer to follow instructions. Okay, right. So, hold on one second, and say he can't find a video on my channel, so I need to help him. It'll be real funny when you be like, what? I can't find the video. Did you search? Did you search for the video? That's a very interesting question. Get shareable link. Comes to chat. Find the link. Oh, Fate beat method. Yeah, Fate beat method. Literally the answers to the yeah. The June 2021 paper plan. Yay. Right. You're welcome, sir. Right? Yeah. Glad to help. Yeah. Alright, so back to what I was teaching, because searching a YouTube channel is so hard these days. Don't worry, you could go and download the app and you could check the website. We redesigned the website and we redesigned the apps so that it'll be better for you. So probably by middle of the week I'll launch over the app on the website and you'll be able to find everything. Anyhow, so now that we know the data types that a computer could understand, we are happy. Now we could try to actually talk to the computer. In order to talk to the computer, we have to use something called memory, right? And that brings us to a thing called constants and variables. For us, we have many variables in life. We have the variable things will be like your age, your the amount of your height, the amount of food you could eat. All sorts of things are variable. And based on those variables, we make decisions. So if outside is wet, outside could be wet or dry, is a variable state. Based on if it's wet or dry, we make decisions. And our computer has to be able to make decisions if we're going to write programs. So in order to do that, we have to create a world where constants exist for the computer and where variables exist for the computer. That means we're creating a world where things could change or things could stay the same, so that the computer will be able to follow our instructions based on the state of a variable. Because if you tell the 3-year-old, go outside, if it is dry, then the 3-year-old will say, okay, I have to check to see if the variable dry is correct, and then it'll go outside. So constants and variables is just a way to help our computer understand what is really going on, right? So A constant is like a memory location where there's a fixed piece of data. So, for example, gravity is 9.81. Cool, gravity is 9.81. Wonderful. If I take a space in memory and say computer, this is a place called G. G stands for gravity. G is always going to be 9.81, and I put a number inside there. I have put in a value inside. Now that value that I put inside there, you realize is a floating point or a real number because we just went through decimals, right? So if I put that number inside there, the computer will be like, yes, I know exactly how to interpret this number, and now I'm going to associate that number with G. So now we've created a constant. So the computer will be like, every time I see G, I will know that it's supposed to be 9.81. It's like a kind of substitution thing, you know, like how you substitute something inside X, like let X be equal to 3, that kind of thing. Yeah, that's what you will see. Variables, however, variables are like a location where the information could be changed or is changeable. So if I say, computer, this place is a place called N, and it stands for a number, that means a number could be anything. So anytime you look at N, I need to check inside the box and see what the number is. So let's say N stands for number of siblings. Your number of siblings, if your parents decide, well, or it may just be a mistake. Well, not a mistake, no child is a mistake, but you know, things could happen. And then all of a sudden your number of siblings goes up from 3 to 4. And you feel sad because nobody cares about you anymore, because all they care about is the baby. But that's okay. When you see the baby getting all the attention, don't be like this.
Oh my God! Oh my God!
Like you give the child my food? How you gonna feed the baby my food? And then you'd be like, but you're a big horse. Like, you're not supposed to be drinking milk like that anymore. I must give the baby the milk. So yeah. So if your number of siblings go up and you're like, dog, why the number changing like that? If you were to tell a computer how to go through variables, the computer would be like, all right, every time I want to know what N is, just check to see what it is inside this box. And N could be 3, it could be 4, it could be 9, it could be 20. Doesn't matter because it's a variable. Variables change. The temperature outside changes. The amount of gas in the car changes. All those things are variable. Constants don't change. So when you set a constant, the computer will know, all right, every time I refer to the constant, it's always going to be the same each time. Now, with this in mind, if we have data types, which is we know the numbers we could use are whole numbers, decimals, and we could use characters, and we know how to use variables and constants, now I could start to give instructions to a computer because I know exactly what the computer understands. The computer understands numbers and characters and variables and constants. With those 4 things, 5 things if you want to call it like that, because it has whole numbers, decimals, characters, variables, and constants. With those 5 things, I now have the ability to give instructions to a computer because now I could speak the computer's language. And if you can speak the computer's language, you win. You're really gonna stand up and be like, wait, I'm a hacker now. And you're just... But you're not at that level yet. You're really not that good yet. So take your time and understand how we actually doing this, right? So after variables and constants, we now know how to talk to a computer. We could write a pseudocode. And remember, I told you, do not say pseudocode. If you say pseudocode, yeah, please, don't say pseudocode. If you say pseudocode, I'll want to find you and jump kick you. Like, I don't want the world to think that the word is pseudocode. Stop it. Stop it now.
No! God, please, no! No! No!
Right, so now that we established that the word is pseudocode. Pseudocode. Pseudocode means pseudo is basically the meaning or type of code, right? Type of code. If it's a type of code, then you are going to be saying the instructions to a computer in a way that it will understand, but it's not really code, as in a programming language. You are actually writing it in a form that's in between English and the actual code. So that's why it's called pseudocode, because remember I told you all, the starting point is English, and the end point is 1s and 0s. So if we come in the middle of here, the 1s and 0s is called code. So if you come in the middle of here, we get pseudocode. Right, so somewhere around here is pseudocode. Good. Right? So pause for a second. This person paper 129, excuse me, so I'm a Form 5 student, I'm doing an ITSPA, and I was watching a video on database, but I can't access it anymore. Just look in the description of the video. You'll see I updated it. I literally updated it, and there's a whole new playlist with the videos done over, and they are a lot more detailed and they have more information. But apparently, like, life is so hard. I literally put in the comment of the video, this video has been replaced by a more updated video. Click here to see the playlist. Should I do more? I don't know how much more to do. Why? I really don't know how much more to do. Did you see that in the comment part of the in the description of the video? This video has been replaced by a more updated video. No? Didn't see it? No? Yeah, well, click the link. You'll see I split up every single thing into the separate parts, and I have a video focused on each section, and I go into a lot more detail. Nah, it's no way you could find the older video better. No way you could find the older video better. Because the new one, I did things, I fixed mistakes that was made in the other video, explain things that I didn't explain before. All the comments that people gave on the older video, I was like, okay, cool, I'm gonna do it over and I'll update it with newer things and explain all the questions that people had. Like, you can't tell me the older video is better. The old video, the sound was poor, the screen was blurry, all kind of things was wrong with that video. But it reached 50,000 views on YouTube because people needed it. So the reason I did it over is because I wanted to make the viewing experience better and fix the errors that I made. So I just letting you know, you definitely do. And plus it have chapters in the new video. Like, my life so hard, boy. My life so hard. Imagine I put in chapters now. Like, take the time to update the video, put in chapters, lay out everything neatly, and come and say you still prefer the older one, man. I real hurt. Watch. Just now, I need to make this. Watch standard. Watch is standard. Like, the thing laid out. There are timestamps. Watch. Timestamps. If you want to jump to a particular part, you jump to that part of the video. If you want to just do the query one, you click on the first query, you get there. If you want to do the calculated query, there's literally a breakdown of every single part of it. Alright, I'll stop now. You're welcome. I'm leaving out the Excel imports. Nah, I ain't leaving out the Excel import. Importing the data. No. You had to create, like, you had to type up your information. Like, how could, like, I don't know, boy. I don't know. Man, tell me I'll leave out the Excel import, yes? You mean creating data in Excel? I'll try. Anyhow, as I was saying, so pseudocode is a type of code. Now, because pseudocode is a type of code, you have to now speak the language that the computer understands. So in order to write the same program to read 3 numbers and display the sum, you have to now write this in a way that a computer will understand. In order for the computer to understand this, you are basically going to give instructions using the same pseudocode terms that we said. So notice, instead of saying, if you're writing narrative, you would have said get the value for A. This is narrative. A computer won't understand that. All the computer wants to hear is read A. Now, instead of using read, you could also use the word get. You could also use the word input. But the thing is, this whole long line here has been substituted by a very simple 2-word command, which is read A. That is what pseudocode is about. We have shortened it to the point where the computer will understand it easier. So we have read A, read B, read C. Those are things that the computer likes because we now shortened it, we've used the keyword, and we've given it a variable name. So now we have a variable, so the computer now is now able to say, okay, cool, there's a place called A, there's a place called B, and there's a place called C. And that is what a computer needs. It needs to know, okay, I need a variable A, a variable B, and a variable C. So I put in the information, and the computer now has stuff to work with. And then my next line is, under normal circumstances, if it were narrative, we would have said, find the sum of the 3 numbers. That's a lot of words. This here is narrative. We can't tell the computer that. But what we can tell the computer is sum, which is another variable, so it creates a box called sum, is equal to, because now you realize we use equal to, because the computer cares about using those symbols, which is called a relational operator. So we're relating the A, B, and C. And then we just say A plus B plus C. So this now uses the same terms. So let me go back to where we had the terms. So I was telling you all good. You have to use these terms where you use shorter variable names. You use the addition sign. And instead of saying the word sum, you put an equal sign. That gives the computer the ability to now do the calculations for us. And we are speaking the language that the computer will understand easier, because we're trying to get from English all the way down to code. So right now we're stuck on pseudocode. And instead of saying print out the value of sum, we just put the word display sum. So instead of display, we could have used the word print sum if we want. Okay? So let's try to work out a very simple question, right? So I'm going to work out a question with read 3 numbers, find their average, and multiply the average up by the sum of the 3 numbers. So let's go. So I'm going to try to read 3 numbers. I'm going to say start. In order to read the 3 numbers, I have to use the word read. So I'm going to say get or read or get, right? So I could use any one of the keywords, but I like to use get because get sounds better. So get A, get B, get C. Now, why did I use A, B, and C? What does A, B, and C mean? A, B, and C are variables, meaning they are just boxes that could hold a number. For now, we're not trying to set a data type for it. Later on, we'll understand what data types are, right? How to set the data types. But all I really want to get the computer to do is understand, okay, I want you to know that there are 3 spaces that I have numbers inside of them. What the numbers are inside there doesn't matter to the computer, because I am giving a solution to a problem. I am not actually trying to work out a problem. If it told me to add 5, 5, and 5, then I would tell the computer, get 5 plus 5 plus 5 and put it in a variable. But that's not what I want to do. I want the computer to be able to solve the problem no matter what numbers it gets. So that's why I'm using A, B, and C. Now I could also go back and I could use N1, N2, and N3. I could do that also. But either way, I'm going to solve the problem by getting the computer to figure it out. So then now my next job is to, what the question said to do? Read 3 numbers, find their average, and multiply the average by the sum. Okay. So to find the average, I need to find the sum first. So I can say sum is equal to N1 plus N2 plus N3. And that's cake. Because now the computer will be like, oh, whatever is inside N1, take that number, add it to whatever is inside N2, take that number, add it to whatever is inside N3, and then whatever the answer is, put it inside sum. So I'll pause here and I'll do a simple illustration for you to kind of get, right? So here's the simple illustration. Imagine we're dealing with a 3-year-old child, right? And we say, hey, child, going to give you one envelope, and this envelope is going to be named N1. I'm going to give you a next envelope, and this envelope is going to be named N2. And I'm going to give you a third envelope, and this third envelope is going to be named N3. The child has no idea what is inside the envelope. But remember, I am just giving instructions to this 3-year-old child. This 3-year-old child is what we are going to call the computer. So I'll be like, computer, which is a 3-year-old child, I'm going to give you 3 envelopes. N1, N2, and N3. And because the child doesn't know what's inside the envelope, the child will just take the 3 envelopes. And then we're going to say tell the computer, all right, I'm going to give you a next envelope, and the name of this envelope is going to be called sum. And you say, child, take whatever is inside envelope 1, add it to envelope 2, and then add it to envelope 3. And whatever that comes up to, whatever this comes up to, take that and write it on a piece of paper and store it inside a variable called sum. Store it inside the envelope called sum, and then hand me back. The child doesn't need to know what the numbers are. All the child needs to know is the instructions are get N1, get N2, get N3, and then sum is equal to N1 plus N2 plus N3. That's all the child needs to know. And in the case of the computer, that's all the computer needs to know, because the computer just needs to know the variables that are being used. And once you know the variables that are being used, the computer will just follow your instructions, because that's what it's there for, to follow your instructions. So N1 plus N2 plus N3, put it in a variable called sum. So, how are you check? Oh, yeah. N1 plus N2 plus N3, put it in a variable called sum. So then the next thing I'm going to tell the computer now is average, AVE, is equal to sum divided by 3. Notice I just using the terms, and sum divided by 3, which is usually straightforward. Average is the sum of the numbers divided by 3. And my question said, finally, multiply the average by the sum of the 3 numbers. So the final thing I'm going to have is something called answer, like answer equals average multiplied by sum. That is what the question asks for, so we do what the question asks for. And then when you're done, you like print answer. And that gives you all that you need. So I have now given the list of instructions that the computer has to follow in order to achieve this question here, which is read 3 numbers. Did we read 3 numbers? Yes, we did. We read the 3 numbers here. After we read the 3 numbers, what do? We find their average. Did we find the average? Yes, we did. We found the sum first, and then we divided the sum by 3. Remember, computer doesn't care what the numbers are. All the computer needs is the instructions on how to solve the problem. And then the last thing was multiply the average by the sum of the 3 numbers. Did we multiply the average by the sum of the 3 numbers? Yes, we did. And then we printed it out. So in the end, we had 1, 2, 3, 4, 5, 6 variables. And those variables were calculated based on the instructions that we gave to the computer. So that is how you do a simple algorithm. Understanding the fact that we are writing pseudocode, which is a type of code, something that the computer will understand based on the instructions that we give. But the instructions that we give must center around the fact that we know the data types I could use, aka the language that the computer understands, integers, floating points, and characters. And we understand that there is a constant and a variable, and we could use those 5 things to make the computer do anything we need it to do. But we must speak the language of the computer, which is a type of code called pseudocode. Alright, so I'll take some questions in the chat now before close off. But that's the concept. And next week we'll start to do some of the control structures, which will be selection, sequential, selection, and loops. That's where children tend to get problems. But trust me, I'll make it simple. So look out for that one in the next video. This video is brought to you by makeITsimpleTT. Every class is structured to run on a yearly cycle from June to May. This cycle covers the whole syllabus in 12 months with 1 2-hour session per week, along with assignments that are given weekly. Every class is recorded so students can always go over the work and recap notes in case they miss a class. To register, head over to our website at makeITsimpleTT.com/register, or you can WhatsApp 1-868-308-8799.